Okay, so obviously I'm not here today for class, although I think I'm on campus right now, but I just can't do too much talking still. It causes pain for me to do it, which, kind of makes my job a little bit more challenging. So what I do is I make these videos and I kind of stagger when I make them so I can kind of spread out things a little bit. But just to kind of give you where we're at here and what we're going to be doing, well, for sure we're going to be finishing up section 8.4 today. I'll talk a little bit about what we're going to do. So we're going to finish 8.4. But then what I want to emphasize here is I haven't gotten really any questions via email, which is fine. So what we're going to do to kind of make up for that is 1029, which is Monday. Go over homework from, just hit the desktop there, sorry about that, from 8.1 to 8.4. If no questions, we will move on. If I could spell move. So this is going to provide us a time to go over any questions you might have on these sections, things that maybe you didn't understand in the videos 100%. But again, you need to really look at the homework. I will try and get solutions posted for the homework. I know they're still not up there for these sections. I'm doing my best. I will try and get them up there. But then also want to announce that on the 31st, which of course, happy Halloween, we will have a quiz covering 8.2 to 8.4. And this quiz, you will be allowed to work in groups. You do not have to work in groups, but you'll be allowed to work in groups. No more than 2 people to a group. I never really liked working in groups when I was in college, so if you choose to work by yourself, that's fine. But you're allowed to work in groups. If you do work in groups, you'll turn in 1 quiz per group. And then, of course, we'll continue on from there. And hopefully, we'll be able to get back to some more regularly scheduled class meeting times as well. So let us continue on with where we're at. So just to kind of summarize where we've been at here is we've got, I'm going to summarize a little bit here because, we've kind of started going through chapter 8 and there's been a lot of things we've talked about, and then, I've been out because of my health. So let's kind of just summarize where we're at here. So the first thing we talked about was sequences. And that's where we had these curly braces and we had something like a sub n, and it went from n equals 1 to infinity. Now, classic problem here, I'm just going to do one quick example of this because this is going to be what you could expect on an exam or even on the quiz. So let's just go ahead and look at this sequence here. So write the first 5 terms down. Now let's say instead of 5, let's do 4. Write the first 4 terms down. Now, actually I'm going to change this index from 1. I'm going to change it to 0. Just to make sure that we're all clear. When we say first 4 terms, we're literally talking about the first 4 terms in the sequence. So I'll make a little table here. So I'll say term, n, and then a sub n. So first term, second term, third term, fourth term. But in this case, n is 0, 1, 2, and then 3, because I just start with wherever n is. So my first term is when n is 0. And so then, of course, we plug in these in here. So you'd have 3 times 0 plus 1 over 2 times 0 plus 3, which be 1/3. And then continuing on, you'd have 3 times 1 plus 1 over 2 times 1 plus 3. So this would be 4/5. Continuing, 3 times 2 plus 1 over 2 times 2 plus 3. So what would that be? 7/7, which of course is just 1. And then we'd have 3 times 3 plus 1 over 2 times 3 plus 3, which would be 10/9, assuming I did all my arithmetic correct. So those are the first 4 terms of the sequence. Nothing really surprising there, that's just basic arithmetic. But then the next part would be determine if the sequence converges or diverges. If it converges, what does it converge to? Okay, so to do this, remember all we're doing is evaluating a limit. All we have to do is look at the limit as n goes to infinity of a sub n, which is equal to the limit as n goes to infinity of 3n plus 1 over 2n plus 3. Now there's several ways you could evaluate doing this limit. One thing is multiplying everything by 1 over n, but I like to just remember that if we have a rational function here, that you can really just look at the lead terms. The lead terms of the numerator and denominator dictate the behavior. So this is the same thing as looking at the limit as n goes to infinity of 3n over 2n, which is just limit as n goes to infinity of 3/2, which of course is 3/2. So the sequence converges to 3/2. Great. No problems with that. Now that's really all we talk about with sequences. That's about it. And that's kind of the extent of the types of questions you should expect with sequences. The only additional things you could expect with sequences, and we've done these in class, is like give an example of a bounded sequence that doesn't converge, or give an example of a bounded sequence that does converge. We've done that several times. Those are the only other types of questions. Those will most likely show up on an exam though. Alright, so then the next thing we talked about was series. And we kind of introduced them, but really series, remember, these are infinite sums. And so what we're looking at is typically it's in the form of k equals 1 or might be 0, a sub k. Now, a couple of the ones we've looked at, and this was in section 8.3, we looked at 2 very special cases, because remember with a series we're always looking for 2 things. One is what it, if it converges, and then if we know it converges, what does it converge to? So in 8.3 here we had geometric and telescoping. And so the geometric here, remember that these were in the form, and I'll do an example of this again as well, just to kind of refresh us all here. I just feel like we kind of have rushed through some of these things, so I want to do an example here. Geometric sequence was in the form of a times r to the k. And basically, if the absolute value of r was less than 1, this converged to a over 1 minus r. So not only did we know that it converged, but we knew exactly what it converged to. And then if the absolute value of r is greater than or equal to 1, the series diverge. Now the only thing, remember, that you have to be careful with this formula is assuming that you're starting at k equals 0. So let's do one quick example just to refresh us again here of what we have going on here. So let's look at, and I'm going to purposely do this here, k equals 1 to infinity of 4 times 0.2 to the k power. Now the issue is, this is definitely a geometric, and it definitely converges. We have a is equal to 4, and we have r is equal to 0.2, which is clearly less than 1. But notice here, we don't start at 0. Now we did talk about how to make it so it starts at 0. What we basically do is we just change the variable here. So how do I get 1 down to 0? Well, we just subtract 1. So what we're going to do here is we're going to say, well, let's let m equal k minus 1, which this then implies that k is equal to m plus 1. So I'm just going to rewrite my series. And now, if I'm starting at k equals 0, I'll now start at m equals 0. I'll still go off to infinity. Then I have 4 times 0.2, and now it's to the k power, so this would now be to the m plus 1 power. And then the other kind of trick we had to do here is recognize that, well, wait a minute, what can I do here? I can separate this out. And I'll go ahead, even though we don't write it here, that would be 0.2 to the first power times 0.2 to the m. And let me just grab my calculator here, because I don't trust my, although I should be able to do that, 0.8, 4 times 0.2. Wow, this is a bad morning here. I'm doing this at 7 in the morning on Thursday. I've actually got an MRI scheduled for some time today. So m equals 0 to infinity of 0.8 times 0.2 to the m power. Now this is absolutely in our geometric series form, and this is a is now equal to 0.8, r is equal to 0.2, and so the series converges. To 0.8 over 1 minus 0.2, and I really did just pick random numbers, but I somehow managed to pick random numbers that gets this to converge exactly to 1. Now, the last thing I want to just kind of review in this video, and then we'll get into new material in the next video. Taking a sip of my coffee there. Last thing I want to review here is the telescoping series. Now I'm not going to do a lot of these examples. I'm just going to remind you of one here. Remember, you might have to apply partial fraction expansion. I'm not going to do an example with partial fraction expansion though. So you might have something, for instance, like the sum from k equals 1 of 2 over, let's say, 3k plus 1 minus 2 over 3k plus 2. Okay, so in order to know that this is telescoping, you have to kind of just plug some numbers in here. So if we plugged in 1, we'd have 2 over, and I'm not going to reduce things down here, so we'd have 2 over, well, 1 would be 4, minus, this would be 2 over 5 then. And then let's write the next one down for k equals 2. Plugging k equals 2 in, we'd get 2 over, and I picked a bad example here. Let me change some things here. Let's try this one here. Let's erase some of this stuff. Sorry about that. Alright, let's start over here. I picked a bad example. I picked an example of a series that's not telescoping is what I did. So let's look at this one instead here. Series from k equals 1 to infinity of 2 over k plus 1 minus 2 over k plus 2. This one I know for sure is telescoping. So again, we need to write the first few terms down here. So this would be 2 over 2. Again, I'm not going to simplify. Minus 2 over 3 plus, this would be 2 over 3 minus 2 over 4 plus 2 over 4 minus 2 over 5 plus going on forever. And what we can see here is this is telescoping. You have minus 2/3 plus 2/3. Minus 2/4 plus 2/4. And so what we can see, because it's telescoping, this is going to be equal to 2 over 2 minus the limit of the second term. Because we're always going to have that minus 2 over k plus 2, because we never get to cancel that one out. If we stop the series at any point here, we'd still have that minus 2 over something. But what we do is we'd have 2 over 2 minus the limit. And of course 2 over 2 is just 1. And then this limit is 0. So this would be equal to 1. Alright, so in the next video I'm going to quickly review the divergence theorem, and then we're going to move into the integral test for convergence.